Um, as you mentioned in your introduction, I'm talking about ableism by design in human-like AI. So for this study in particular, we interviewed designers, researchers, and engineers who are working on AI agents and tried to see like how they're implementing humanness in their technologies. And before we begin, I just wanted to remind everyone that how like the concept of artificially generating human communication sort of began. So in the 1950s, Alan Turing proposed his imitation game, which is now known as the Turing test. In that, he basically said you can measure a machine's intelligence by how well you can benchmark a machine's intelligence by how well it can imitate human communication, and from this, we saw in the 1960s the development of the first AI chatbot. It was called Eliza, and it basically just used keyword-based pattern matching. So it had like a script that it followed based on certain keywords in your conversation. And then from that, today we have LLM-powered chatbots, which are definitely becoming more and more human-like. So if human communication has become a benchmark for measuring machine intelligence, then how we define human communication matters. And that's sort of where the problem arises. This was discussed even in the previous conversation, this whole idea about norms. So if we're using neurotypical communication styles and saying that they are the norm of how human communication should be, then based on those standards, autistic people are seen as being impaired, incompetent, and needing skills training. And unfortunately, these biases are actually rooted in historical research that question the humanity of autistic people. In fact, in this particular paper, Baron Cohen compared autistic people to chimpanzees and robots and said that they're less human than them because they lack a quintessential ability that makes us human. Oops. So as you can see, we sort of started pivoting towards neuronormativity at the very beginning of when we started studying autism itself. And we see these biases even in the media today. You see a lot of headlines that link AI to autistic people, saying that AI either talks like autistic people or like has a similar thinking or writing style. But there are alternative ways that we can look at this. So, for instance, if you're looking at a miscommunication between a neurotypical and a neurodivergent person, instead of viewing the neurodivergent person as having a deficit, what if you viewed it as a mutual problem? So it wasn't that the neurodivergent person, the autistic person in this case, is struggling to understand a non-autistic person, but it's that both an autistic and a non-autistic person struggle to understand each other. So that means that instead of just focusing on fixing the autistic person, we can actually focus on teaching everyone how to communicate with each other. And we view them all neurotypes as just being valid and different ways of communicating. So back to our study, prior work has actually shown that LLMs have a tendency to overclassify autism-related sentences as toxic, so that can lead to community censorship if you're using these models for any sort of content moderation. And we also know that in most AI datasets tend to portray autistic people and their behaviors as a deficit. And because of that, we see the results are most AI applications will focus on providing diagnosis or medical treatment to to autistic individuals. But one thing that we should think about here is whether or not these outcomes are actually matching the creator's intentions, because intentions are not always the same as impact. And that's kind of what we looked at in our study, their intentions. So we interviewed 16 researchers, designers, and engineers who were working on human-like AI agents. So you can think about robots and chatbots as an example. And we conducted semi-structured interviews that we recorded with their consent. And on the data that we collected, we did a phenomenological analysis. So essentially, we tried to look at each person as an individual rather than looking at them as a group, and tried to understand their experiences and perspectives within the context of their own life. And we ended up publishing our paper. I hadn't thought about that at Fact last year. And when we started analyzing our data, we actually saw instances where we were humanizing machines while dehumanizing humans. So, for example, these are direct quotes. A lot of participants in our study said that using numbers or text-only responses or odd or off unrealistic facial expressions feels less human. And a lot of the participants also said that they specifically focus on communication, emotions, and appearance as the three main ways in which they are implementing humanness in their bots. So when we're looking at these particular standards, whose standards are we judging them by? Like when we say if facial expressions are odd or not quite realistic, what does realistic or something that's right even mean in this context? And we also saw examples of accessibility without neuroinclusivity. So this was really interesting. We actually found that 7 out of 16 of the researchers we looked at were aware of neurodiversity. So they knew that autistic people exist and that they have differences in communication styles. And yet still, 12 out of the 16 did not consider their needs in designing technologies where the sole focus is communication. So this was a quote that we took directly from a participant who was very unique in our study because they were the only ones who we looked at who were actually focusing on working with autistic people. And they said, for the neurodiverse population, the fact that we are designing for them at all, there's an outsized appreciation for that. And I think that's basically because they're a commonly neglected or ignored community. So even the researchers who work with autistic people can see that there is a lot of um, uh, uh, there's a lot of appreciation for this type of work, and yet it still continues to be rare. Another interesting thing that we noticed in our work was why exactly these some of these biases are happening. So for instance, we found that a lot of AI creators will say that they're influenced by other people. So they'll directly give us quotes and they'll say, we tried to mimic others or we tried to recreate whatever, like ChatGPT or whatever technology. And yet 12 out of 16 didn't believe their work would influence others. So while they were influenced by other people, they didn't think others were influenced by them. And similarly, a lot of creators tended to think that ethics is beyond the scope of their work. And so they thought, oh, there's another team that handles that, not really us. And even those who were interested in working on more accessible and inclusive technologies were often limited by their organization's priorities. So the organization wanted to like move fast and release a product. And so accessibility was always like not really the forefront of what they were trying to do. So we saw there was this separation of ethics and tech. And this really matters because we know that virtual interactions can impact real world perceptions. So prior work has shown that video games and avatars that are more diverse can actually influence people into having more inclusive conversations in real life. And this is known as the contact hypothesis, where interacting with someone outside your group actually decreases your prejudice towards that group. So there is definitely value in trying to make AI more neuro-inclusive and how in ways in which that can lead to autism inclusion into society in general. And yet we're continuing to define humanness using neurotypical social norms. And because of that, we see examples like this. Here's a professor, Dr. Williams at Purdue. They received an email that accused them of using AI because their emails significantly lacked warmth. And then the professor responded with, "It's not AI, I'm just autistic." But yeah, as you can see, whoever sent this email had a norm in their mind, and they had like this sort of idea of how a human communicates versus how an AI is supposed to communicate. For them specifically, that meant the presence or absence of warmth. And using that stereotype, they actually ended up dehumanizing an autistic person. And so our recommendations for moving toward more inclusive work basically focus on prioritizing clarity over humanness. So what we mean by this is when you're trying to work on your technologies, instead of just focusing on making it resemble a human being, like try to make it so that it speaks more clearly, and offer customization and control, because every person has different access needs, like every disability. They might have like a, even autistic people themselves, like it it will be, their experiences will vary based on their own like individual needs. So offering customization and control is really important. And then also rethinking success metrics. So far we've like used the imitation game where we're trying to see how realistically an AI agent can mimic like a human speech. But what if we instead looked for measuring logical consistency or practical utility? What would that look like? And the final most important recommendation is to build diverse teams, and avoid tokenization. So what we mean by this is you have to give autistic people decision-making power in studies or projects that involve them and affect them. Instead of just like saying, I have an autistic person on the team and like their value isn't really carrying much weight. You need to make sure that their voices are being centered in the projects. And before moving on to defining neuroinclusive AI, I just wanted to mention, since today's topic is about like AI in the workplace, um, if we do end up like moving towards more neuroinclusive AI, we will see through the contact hypotheses that there is a possibility of there being more autism inclusion. And I just wanted to conclude this presentation by defining neuroinclusive AI. And that's basically just decentering neuronormative benchmarks and challenging the goal of merely mimicking humanness. So instead, you prioritize understanding, accommodating, and empowering diverse neurotypes. So again, this is, you can think of what we said earlier as a good example of this, like rethinking your success metrics, focusing on logic and practical utility. That can be a good way to like for you to move away from like that benchmark that focuses on making your technologies look and sound more human. And that was pretty much it for today. If you're interested in accessing our paper, here is the QR code, and my socials are just scientist in pink. So you can look for me on any social media platform with that name.